Triggers for mould growth. What are they? As previously discussed, mould spores are everywhere, outdoors and indoors. For a mould colony to grow, you only need one spore to successfully germinate. The conditions for germination and growth are the presence of moisture, a surface which has nutrients on it, and air. While mould relies on the movement of air to disperse its spores, for growth it favours conditions where the air is still or stale, which usually means that it grows best where it is hidden. So why does mould grow in some places in your home and not others? In this video, we are going to go a little technical. Firstly, most people will associate mould with condensation. It is true that buildings that suffer from condensation problems are the most likely to develop mould growth, especially in those areas which are repeatedly affected. But condensation happens when the air reaches 100% relative humidity, in other words at the saturation point of the air, also known as the dew point. But mould does not need 100% relative humidity to germinate and grow. Some species of mould will grow when they are exposed to a relative humidity as low as 66%. These are referred to as primary colonizers. These are the organisms whose evolutionary niche is to be the first to exploit the available food source. This slide shows types of mould and their germination requirements. This means that the population of spores settled around the surfaces in your home will not germinate if all the surfaces remain under 66% relative humidity. Okay, so what do we mean by relative humidity? Humidity is the amount of water that's in the air, but relative humidity is a percentage of the maximum the air can hold at any given temperature. Here is a question I ask in some of my training classes. Which of these conditions contains the most amount of water in the air? Most will say that 90% relative humidity is the wettest condition, but the answer is it depends. It depends on the temperature. Relative humidity is relative to the temperature. Here is the same set of relative humidity conditions, but this time with a corresponding temperature. Now we can work out which is the wettest condition. To work this out, we need to understand the relationship between water vapor and the air. This can be expressed in the form of a chart like this. This chart represents a relationship at sea level and is the basis of the calculations used by many in the engineering, ventilation and water damage restoration industries, among others. It is not our intent to describe how this chart is arrived at and all the various scientific data that it maps, but we can use the chart to establish how much water there is in the air expressed as vapor pressure or humidity ratio. For the purposes of this video, we are going to use humidity ratio, which is expressed in grams per kilogram in the metric world. Okay, so let's run the numbers. 90% of 5 centigrade gives us 4.9 grams of water per kilogram of air. Now let's not worry about the grams per kilogram bit just yet. Let's just compare the numbers. 70 at 10 gives us 5.4. 60 at 14 gives us 5.9. 50 at 20 gives us 7.3. 35 at 27 gives us 7.8. Now if you agree with me that 7.8 grams is a bigger number than 4.9 grams, then we can see that the air mass that has the greatest moisture load is at 35% relative humidity and 27 centigrade, and not the one shown at a condition of 90% at 5 degrees centigrade. Just to get it over with, what is a kilogram of air and what does 7.8 grams of water per kilogram of air mean? Okay, at sea level, a kilogram of dry air occupies a volume of 0.833 cubic meters. That changes with altitude, which complicates things, but most organisations in the water damage industry work on this calculus. Most buildings in the UK are close enough to sea level for it not to make any difference. What does the grams of water per kilogram of air mean? Well, if you had a 5 milliliter spoon, more or less a teaspoon, of water, and all that water was evaporated into a single kilogram of dry air, you would now have 5 grams of water vapour per kilogram of air. The metric system makes that really easy. Now, how can we use this information? Well, here's a simple example. Imagine a room in an old Victorian house. Its position is on the northeast corner of the property, the north being the coldest wall, especially in the winter months. The red blocks indicate a solid red brick wall. The other colour blocks indicate windows, doors and internal walls. Let's take a reading of the indoor conditions. If the readings are 60% relative humidity and 20 degrees centigrade, then the humidity ratio is 8.8 grams of water per kilogram of air. Because water seeks its own level, equilibrium, whether a solid, liquid or a gas, that will be evenly distributed across the whole room in normal circumstances. But what happens if the wall is cold in a particular spot? Let's say the surface temperature of that area of concern of the wall is 17 centigrade. Well, if we know the amount of water in the air is 8.8 grams per kilogram in the middle of the room, it'll be the same at the wall, because that has to be true across the whole room. Remember, equilibrium. If the temperature of the wall is 17 centigrade, then the sliver of air closest to the wall surface is 73% RH. That is a number high enough for some moulds to germinate and grow. How do we avoid this? We have another video that goes into a bit more practical detail, but in principle we have to reduce the amount of water in the air. We have to make sure that the heating system is adequate and warms the wall sufficiently so as to avoid not just the dew point or condensation, but also to keep it away from a humidity level of more than 65% for any extended period. Or we need to do both. We should also manage and maintain our buildings to ensure that we do not allow water to penetrate the building envelope, as we discussed in video 2. Remember that here we are using a cool wall as the example, but this could apply to any surface where spores may be present and where it can feed, such as shoes, handbags, curtains, wallpaper, books, and so on. The warmer the material, the less likely it is to have mould develop. So, what do we want our conditions to be at home? The short answer is to try to keep your home at 18 to 21 centigrade and an RH of between 50 and 55% for most of the time. This equates to a humidity ratio between 7.3 and 8 grams per kilogram. Your home is at risk when the relative humidity in your rooms is above 60%, especially when it translates to more than 66% on any mould edible surfaces where temperatures may be lower. Final note in this episode: while most moulds prefer moderate temperatures of 20 to 30 centigrade, many will grow at lower temperatures. Mould can and does grow in your fridge. We'll discuss unresolved water damage issues and the practical management of humidity in your home in future episodes. Thank you for watching.